Okay, first, online friends, please do that survey that I posted. I really need that information to help me make some choices on moving forward. So it's an easy 5-question survey. Please knock that out. Won't take you long, and it will be very helpful to me. So thank you for that. All right, looking ahead, we got good news and bad news. Which do you want first?
The bad news.
You always want the bad news first, but it's really not. I mean, I'm kind of hamming it up. It's not bad news, but you think it's bad news. As you look at what's coming up in the next 2 weeks, what's the word on there that makes you,
It is proof.
Hey, yo, I want proof that there's no
Okay, good news, though. Well, 2 pieces of good news. Probably I was going to say best. I don't know which one's best. They're both really good. Trig proofs are not like geometry proofs, okay? So some teachers don't want to use the word proof at all, and just that way it doesn't get the bad taste in your mouth and we never even say it. I prefer to just confront it head on. They are proofs, but they are not like geometry proofs. Like geometry proofs where you had to state something and then the reason, like the definition of alternate interior angles or corresponding parts of a, whatever that was, of a congruent triangle or congruent. Like, it is not like that, okay?
What is it like?
It's really not. We're going to do some today, and really I didn't even call them proofs today because they're so different than geometry proofs. So get the geometry proofs, let that taste get out of your mouth. I know it's a bad memory. So that's the bad news, good news. The other good news is we'll test next Thursday. I guess that's neither good nor bad. But next Friday is a makeup day, remember? So that means if you're caught up on everything, we're good. If you still need to make something up, then that Friday I'll be hounding you to, hey, take this test, turn something in, whatever. Vast majority of you, though, you take care of your business, and so Friday you sort of earned I can't even bring myself to say it.
An off day.
Free day.
mental break.
A mental break. We can phrase it that way. Yeah. But hey, you earned it. If you kept up with everything and you're good, then I'm good. Plus, some of you are probably absent, and it's kind of worthless to teach a lesson
Is there anything on Wednesday?
day before a week off. Got a couple review days built in. So this really is not a bad unit. In fact, the worst part is the inverses. Inverses are worse than proofs.
I think I'll be absent.
But that's only because proofs are not bad. All right. Enough of all that. Let's talk about trig identities.
Dude, can I sleep through the entire class for next time? He has to wake me up on a daily basis. Multiple times.
Okay. Actually, today's notes, I think you're going to know everything that we're...
Isn't it Unit 10?
Is it Unit... Yes, it is Unit 10. It was Unit 11 last year. So when I look at my notes, it says Unit 11. So it is Unit 10. Trig identities. The identity... Well, let's back up a second. Sometimes we jump into notes and we haven't even defined our terms here. So trig, that means we're talking about sine, cosine, tangent. And the other three, the reciprocal partners of those three. An identity, I think we've used this word in math before, but we don't use it often. It's a statement or an equation that is always true. A statement or an equation that's always true. And so we're working with equations today, but we're not really solving them, like getting an answer x equals 7 or x equals pi over 4. It's more like x times x equals x squared. You're like, well, yeah, that's true. And it's true because it's an identity. Like the definition of x times x is x squared. Check. Now that's super, super simple, but that's what we're going to be doing today. We're going to work with one side of an equation, make it look like the other side, and that's our proof. That's a proof.
So we don't have to do any explanation.
So there aren't explanations.
So we just have to prove that that's actually true.
Correct. Now there are a couple of things about proofs, but we'll talk about those when we get there.
Maybe okay.
Yeah, you'll be
So
fine.
far.
You'll be fine. You're so worried about proofs. Reciprocals. The reciprocal identities. Good news is you already know these because we kind of taught them along the way. The cosecant of theta. What's that equal to? Who is his partner? Who is sine? And how is he partners with sine? The flip of sine. So cosecant is equal to 1 over sine. And the secant is equal to 1 over cosine. And the cotangent is equal to 1 over tangent. It's like, yes, we know all of this stuff. The next column, we know we usually don't think of them this way because we don't need to think of them this way. But if cosecant is 1 over sine, then sine is, it is sine over 1, but that doesn't really help us. It's 1 over cosecant. That's kind of the same equation, just rearranged. And well, let's keep going. So that means cosine is 1 over secant, and tangent is 1 over cotangent. Generally speaking, we need the left-hand column more often than the right-hand column, because when we're simplifying things, if sine, cosine, or tangent is sitting there, we're usually okay with that. Why would we change that? If cosecant or secant or cotangent is there, it's like, we might want to change that into something else. So we need to know both columns, but usually the left-hand column is more helpful. Right, 2 more pieces of information that are also reminders, I think. Tangent. Yes, it's 1 over cotangent, but when you're trying to find tangent, like on the unit circle, what do you, that's what I'm looking for. Sine over cosine.
He's learning.
I just learned this like 2 minutes ago.
That's right.
That's good.
Tangent is sine over cosine, which means cotangent is cosine over sine.
Whoa.
And so it kind of depends on the problem as to which statement of tangent is more helpful. Like, should you leave tangent? Maybe. Should you replace it with sine over cosine? Maybe. Should you replace it with 1 over cotangent? Maybe. Not likely on that one, but maybe. So as you do more of these and get used to them, you'll become quicker at knowing which substitutions to make. Okay, we're going to verify some things today, which just means show that it's true. In some ways, it's like we're giving you a question and we're giving you the answer. We're just saying, show me that that's the answer. And so instead of thinking of it as a proof, it is a proof. Think of it as a problem where you already have the answer. It's like instead of having to look in the back of the book for the answer, it's right there. You just have to show the work to get there. And none of these are going to be like tricks where it's like, hey, show this works, haha, it doesn't work. No, if it says verified, then it's going to work, unless I made a mistake, which is possible. All right, some rules though for verifying or for proofs if you're not afraid of the word. Surely we're not afraid of the word. You can work on only one side of the equation. This is a little bit different than what you're used to. Right? You're used to thinking in terms of, add 3 to both sides, or multiply both sides by 12, or take the square root of both sides. You can't do that. You can only work on one side of this equation. One side at a time. No, not at a time. Just one side. To make it look like, to make it match the other side. Work on only one side to try to finagle it to match the other side. You can pick either side to work with, but usually so that's a rule. I don't know why I numbered it 1, because let's just call it a rule as opposed to some hints. So hard and fast rule, you can only work on one side. Now a couple of hints that might make this easier. Usually you pick the most complicated side to work with. Pick the most complicated side to work with. You'll see why this makes sense later, but it's a whole lot easier to take a complicated expression and simplify it down, as opposed to starting with an easy expression and trying to figure out how to expand it to make it more complicated to match the other side. So almost always, if you'll pick the side that looks the worst and play with it and work with it, you can make it look like the other side. So I guess I should say usually, because this is not you can do it without doing it this way. And then this next one, you know what? I should redoing my notes on the fly here. Number 1 is a usual thing. Number 2 is a sometimes thing. And I would say if you're stuck and nothing else seems to work, put all functions in terms of sine or cosine. Put all functions in terms of sine or cosine. Right, there's 6 functions: sine, cosine, tangent, secant, cosecant, cotangent. But all 6 of those can be written in terms of sine or cosine. So if you're really stuck, you can put everything in sines and cosines, and then you're only working with 2 functions rather than 6. Sometimes that's helpful. Sometimes you can figure it out without doing that. But it's a hint to keep in mind if you need it. All right, let's do some of these problems. Prove. Sine of x over tangent of x equals cosine of x. Again, this is not an equation to solve. This is an identity that's true that we want to show that this equals this. Now, which side, and a lot of times people will draw a line to sort of emphasize that I need to work on one side or the other, not add things to both sides or multiply both sides by something. Which side looks more complicated to you, the left or the right?
The left.
The left, right? With cosine, like what could I do with cosine? Probably not much. I could change it to 1 over secant, but that wouldn't help anything. So let's work on the left-hand side of this one. Not much I could do with sine. What could I do with tangent? What's tangent equal to? I got 2 options. 1 over cotangent, but that doesn't really help me. If I rewrite tangent as sine over cosine, oh, now we're getting somewhere.
But you can put it and multiply it and flip it, and then you just cross them out.
I can do the keep it, change it, flip it thing.
Delicious.
So sine of x times
Sine of
keep it, change it, flip it, times cosine of x over sine of x. Then the signs cancel. And I've got cosine of x, which is what we said we would get. So you work on one side until it matches the other side, and then you're done. And that was a proof.
So we don't have to explain it verbally then?
No, you don't have to, that's the difference. In geometry proofs, you have that other column with your statement and reason. Here you don't have to do that.
Okay.
I guess your reason is that sine over cosine equals tangent, but
Yeah.
you don't need to say that.
So just for that, our answer, if it was reversed, would be cosine x equals cosine.
Well, that's a really good question. So what's my answer? Your answer is the whole thing. Kind of so here is a similarity with geometry. The geometry proof, the answer was the whole thing. Same thing here. Your answer is all of that. Your answer is the work shown to get to the answer.
So Will would hate this.
So yeah, you can't just jump to the end. Yes, some people who don't like to show their work, they're like, oh, I can kind of do that in my head. That equals cosine of x. You're like, well, it equals cosine of x because I told you it equals cosine of x. You can't just jump to the end and be like, hey, it works. You're like, no, yes, it works. I told you it works. But you have to show me why it works.
Okay.
So, there may be some places where you can show a little less work, but you got to show your work. All right, this one's a little more complicated because both sides look ugly. Tangent of x over cosine of x
The left one is still more complicated.
equals secant of x over cotangent of x.
Wait, maybe the right one because it's got a tangent.
So you're right to be you're looking at which one's more complicated.
It's got multiple steps.
So algebraically they're the same. It's like one trig function over another equals one trig function over another. So algebraically they're equal difficulty. But look specifically at the trig functions. Which side has the more complicated set of trig functions?
Right side.
I guess right.
I would say the right.
Because it has tangent, but it's also the
You can always work on either side. So if you want to mess with the left-hand side to make it look like the right, it could be done. But I think the right-hand side looks more complicated.
Because it's got two sets of...
Because it's got two weird ones rather than two normal ones, basically. So let's work on the right-hand side. What could we... Yeah, secant's 1 over cosine. And I'm going to kind of color code and draw arrows, but you don't have to do that. So that would be 1 over cosine over cotangent. That still wouldn't help very much.
You guys should go ahead and do the 1 over tangent.
Cotangent.
Tangent or one? Yeah.
So we have options here. I could write cotangent as 1 over tangent, or I could write it as
You can keep going to
cosine over sine.
Yeah.
I'd say keep it as 1 over tangent because
And
you
then do
want
the
it
next
to be
step.
tangent up here.
That's exactly right. As you're working one side, once you pick which side to work on, you keep an eye on the left-hand side. Like, that's my goal. That's where I'm headed. Like, keep an eye over there. If I want to start making things look like that. Cosine sort of showed up. Cotangent, I can sort of turn into tangent.
And you can just copy it, flip it.
Do the keep it, change it, flip it.
Yeah.
1 over cosine times tangent of x over 1, if you want to write it. And this is a little bit particular OCD of me, but when you get done, you're not done until both sides match exactly. So you're going to get to that point, you're going to be like, oh, clearly they're the same. And I'm going to say, yeah, clearly they are, but you haven't written them to be the same yet.
Sine of X over sine.
So can you just draw like an arrow down from the top?
No.
You can. You don't have to put anything over there.
Oh, okay.
So yeah, the question on the left-hand side, do I want to draw an arrow down? You can. Do you want to rewrite tangent of x over cosine of x every time? You can.
Oh, I assume.
I wouldn't. Or you could just leave it blank, and that just sort of emphasizes that I'm only working on this side. I'm trying to make this side match that side. We got there.
Oh man.
That's it for that problem, yeah. Once you make a match, you're good.
What?
1 over tangent of x. Sorry. 1 over tangent of x equals cosecant of x times cosine of x. Well, I'd say neither one of those sides is particularly nice.
Probably the
fix
right.
the right side.
But I think fixing the right side. So tangent's not too bad. I can handle that.
So is that?
Let's fix the right hand
So are
side.
these the reciprocals like here?
So we're using those
So are
reciprocals.
those going to be like given to us, or we have to memorize them?
And you have to know those. We already know those though, right? You know the reciprocal partners. You should. Like on the unit circle, when you had to find cosecant, you know that it's the flip of sine. So you, in theory, you know the reciprocals already. We'll leave it like that. All right, speaking of reciprocals, how could I rewrite cosecant?
1 over sine.
1 over sine.
Then the other one you can do.
Now, be careful. Here's another hint. Maybe I should have put this. Be careful doing more than one step at once. Sometimes you fly past the answer if you change too much. So I think we should leave cosine as is.
You need to show all proof.
See what happens here.
Okay. So you can't just go from like your hands. You can't just go from
You've got to show your work on this.
here. Oh, darn it. Take it here and get the answer. I mean, yeah.
So
Every
what?
single step you have.
Any idea what we should do next?
That's how proofs work. So it sure is.
1 over sine times cosine.
Fair enough.
Oh,
Because you how tall?
I'd probably just keep it as cosine, because couldn't
Cosine
you
over
just do,
sine.
cosine over sine?
Because what's cosine over sine?
Tangent.
and then you just go.
Cosine over sine is cotangent. Now we're really close.
We just do it.
We gotta flip it.
Now be careful. It's so tempting to work on the left-hand side and be like, oh yeah, 1 over tangent's cotangent. They match.
1 over
But you can't work on this side.
x, and that's equal
You
to
can only work on one side.
tan of x.
But what's another way to say cotangent?
1 over tan x.
1 over tangent.
Boom. Equals to that one.
Again, show your work. Don't just say, oh, I can think about it in my head and get there. Like, well, maybe, but I can't grade what's in your head.
Will. That was a personal attack.
If you took that personally, then good.
You're part of the problem.
Wait, hold on.
You took that personally, you're part of it.
I think that's how it works, Jason.
Well, if you
If
didn't take it personally, that means it
That-
doesn't.
Is that negative 1?
Yeah.
Cosecant of negative x, or cosecant x is negative 1.
Cosecant of x minus 1
Yeah.
equals 1 minus sine of x over sine of x.
Honestly, I feel like
Can't you
the
just-
left one would be more, like, I get that one's a fraction, but that's just really simple ones.
Right, this one you could definitely work either way.
Why don't you just put it over 1 and then change it?
'Cause
You
can
could
do
work
fractions
either
of
side.
cosecant.
So
1 over sine.
to me, I think there's an obvious pick, but do you know which side do you want to work on, the left or the right?
Left.
It's like, well, Mr. Wolf paused, so I guess it's the right.
Wait a second, hold up. Sine.
All right, you guys want to work on the
Let's
left?
go to the right, let's go to the right.
We'll work on the left. If you want to work on the left, what's
Because sine is equal to 1 over cosecant.
what's cosecant equal to?
Cosecant is
1 over sine.
No, this is good practice. This is good work as well.
The right side was easier. Now the
Right side might have been easier, maybe not.
A lot easier.
So the right side only has one fraction, which means I'd like the left side to be only one fraction.
you just do 1 over 1.
So how do I subtract fractions?
Put it over 1.
They have to have the same denominator.
They have to have the same denominator.
Oh.
So I need a common denominator. What's my common denominator going to be? Sine of x.
Sweet.
So I'll keep my denominator. I'll subtract my numerators.
Wait.
And we're done. So that wasn't bad.
Hold on. How did it get?
How is 1 minus 1 negative?
How'd you get the sine x negative but keep the 1 positive? Go. Magic.
So
You just flip the sign to a random thing.
no, I did not flip the signs. I gave this 1 a common denominator. I multiplied top and bottom by sine of x to make it have a denominator of sine of x.
I know that part, yeah. But how'd it go from negative in front of all of it to negative just in front of that top sine of x?
Well, this
That's 1.
this one is this one. This one is just, well, 1 times sine of x is sine of x. I don't need to write 1 times sine of x.
How, but 1 times sine of x, that's like 1 is by itself. How is 1 minus 1?
Because it's not 1 minus 1. It's 1 minus sine of x.
Okay.
That's like 5 minus 5x. That's not 0x, right?
Yeah.
So you don't do the 5 minus 5.
Okay.
You're stuck with 5 minus 5x. So we're done with that one. I'm going to quickly do it the other way. You don't have to do this, but I'll show you. This is the way I thought I was going to do the problem. But this is a good one to show that you can work on either side. If I want to work on the right-hand side, they're both divided by sine, so I can put them both over sine. Either way, this is more of an algebra proof than a trig proof. You got to know some algebra. And what's 1 over sine equal to? 1 over sine is cosecant, and sine over sine is 1. So, I don't know, that's arguable. That's why you were debating which side to work on, because they were about the same in terms of difficulty. This also means on the test I have to be careful because there are more than one way to get there. Let's do one more. Secant of x plus tangent of x over secant of x. Oh, sorry. Secant of x plus tangent of x over secant of x equals sine of x plus 1.
Left side.
Definitely the left side, right? Sine of x plus 1, that's pretty straightforward. On the left side. What do you want to do first on the left side?
Do what you did in the one up above.
Yes, do what we did in the one up above. They're both over secant, so I can split them up and put them each over secant. Especially as I'm peeking ahead, I'll get secant over secant, which is 1. So I'm already... Right? You don't just work the problems blindly or work one side without thinking about the other side. You keep an eye on the other side and start thinking, how can I make this work? Like, secant over secant is 1. So I'm getting there. Now I got to turn somehow tangent over secant into sine. That seems a little bit weird, but so what do you think? I heard them both. Tangent is sine over cosine. And secant is 1 over cosine. And if you're careful and know how to cross things out, you could do it from there. I'm going to do the keep it, change it, flip it because it's safer and what some people will stick with. But yes, the cosines cancel. And you're left with 1 plus sine of x. And is that okay as a final answer?
Yes.
Does it have to look the exact same?
It's got to look exactly the same.
No, you gotta change it.
And I know you're going to sit there and argue with me. Come on, Mr. Wolf, 1 plus sine is the same as sine plus 1. I'm going to be like, yeah, it is. But they don't look the same, so Like if we were going to be geometry proofing this, the reason for that would be, what's the
So we would need to type it.
associative property of addition or whatever it is. That would be the reason for that. All right, posted are the worksheet and the keys. So in Schoology, the worksheet packet is posted and the packet of keys is already posted, but I'll hand you the worksheet packet right now.